Okay, welcome back. So we will continue with the fifth subtopic, 3.5, resistor in series and also parallel. Okay, so for series, meaning that the resistor will connected in only one wire. Okay, in only one loop. Okay, so R1, R2, R3 is connected in only one loop. Okay, so because it's connected in one loop, so therefore our current is the same. Okay, current will be the same. Okay, because the current will flowing through from the terminal positive come out, it will flowing through. Okay, it will flowing through R1, R2, and also R3. Okay, so R1, R2, R3 is the same current that we're flowing through, and then come back to the terminal negative. Okay, so our equations, we write it as our I total equals to I1 equals to I2 equals to I3, because the same current will flowing through the three resistors. So assuming that the connecting wire have no resistor, the total potential difference V is equals to, V total equals to V1 plus V2 plus V3. Okay, Y equals to V1, V2 plus V3. Okay, because this is only one battery. Okay, so this battery, the potential difference will distribute for R1, R2, and R3. Okay, so it will distribute R1, R2, and also R3. Okay, so when we total up this V1, V2, V3, it will become our V. It will become our V total because this battery is sharing the potential difference is sharing with three resistors. Okay, next. Okay, if you want to find if you want to find V1, okay, you must use V1 equals to I R1 because I is similar along the circuit. If you want to find V2, you must use V2 equals to I R2. If you want to find V total, okay, you must use V total equals to I R total. Okay, so therefore, our R total for series is equals to R1 plus R2 plus R3. So this is for series. Okay, next. Okay, resistor connected in parallel. If the resistor connected in a parallel, okay, if the resistor is connected in parallel, meaning that this resistor is connected, okay, directly from terminal positive and then connect with the resistor and then connect back to the terminal negative. So meaning that if let's say there's a resistor is connected in parallel, meaning that we have three loop, okay, 1, 2, 3, and three loop is directly connected from terminal positive to terminal negative. So therefore, the potential difference across each capacitor same because it's directly connected positive to negative, positive to negative, positive to negative of the battery. So we write V total equals to V1 equals to V2 equals to V3. Okay. Okay. Whereas for our current, if let's say if you refer to this one, when the current want to come out, it will split into I1, I2, and I3 because we had three junction at here. Okay. So our I total it will split. Dia akan cabang. Okay, it depends on the resistor. If the resistor is high, meaning that the current will flowing through is low. Why? Why resistor high, current flowing through will be low? Because resistor is like macam halangan. If let's say jalan itu, halangan itu besar, maksudnya arus yang mengalir itu pun kurang. Because halangan itu terlalu tinggi. So if resistor high, meaning that halangan tinggi. Halangan tinggi bermaksud arus nak melalui itu pun susah nak melalui. So that's why current that flowing through the resistor is lower. Okay, so it depends on the resistor. Okay, so if the charge is conserved, therefore the total I in the circuit given is I total equals to I1 plus I2 plus I3. We total up. Okay, because it's split. After that, it will combine back and then it will flow back to the terminal negative. So this is I for parallel. Okay, similar, if you want to find I1, you must use V over R1. Okay, I1, R1. Okay, where V is constant because V is V total. Okay, so therefore, if you want to find resistor for a parallel is 1 over R total equals to 1 over R1 plus 1 over R2 plus 1 over R3. Okay, so this is the equations for resistor connected in series and also parallel. Okay, let us try one question. So here we have 3 resistor connected series and also parallel. So we try to simplify it to get R effective or R equivalent. Okay, so every time when you want to do this type of question, similar like capacitor, you must find everything total first. Okay. Okay, so now we try to simplify it. So the first step, you must do series first. After you do series, then only we do parallel. So step 2 is to find parallel resistor. Okay, so step 1, let's say this is R1. Okay, this is R2. This is your R3. Okay, so after combine, we will get R12 and also R3. So first step, we find series first. So R12, because it's connected series, meaning that it's R1 plus R2. Okay, so it's 4 ohm plus 12 ohm. So you will get 16 ohm. Then step 2 is to find parallel. So 1 over R, 1, 2, 3 is actually is 1 over R total lah. Okay, or R effective. Okay, it's equals to 1 over R12 plus 1 over R3. Okay, so 1 over R12, R2 is just now is 16, plus 1 over R3 is 2. So if you press the calculator, R effective, you will get 1.78 ohm. So this is our R total. Okay, you must find our R total. Okay, next, we want to find the current pass through the 12 ohm resistor. Okay, so if you refer here, the 12 ohm resistor, okay, the current total will come up from the battery, and then it will comes to here. Okay, I total. So when it comes to this junction, okay lah, junction A, it will split, become I1 and also I2. Okay, so I1 will passing through 4 ohm, 12 ohm. Okay, so this is I1 and then come back to this junction B. Okay, similar for I2. I2 will flow through 2 ohm and then come back to this junction B. And then when it comes to this junction B, it will combine back. Okay, it will combine back, become I total, and then go back to our terminal negative. Okay, or if you want to refer here also can, I total. Okay, when it comes to this junction, it will split to I1 and also it will split to I2. Okay, so meaning that I1 will flowing through resistor 4 and 12. Okay, and then I2 will flowing through R3. Now we want to find the current passing through the 12 ohm. So meaning that we want to find R2. Okay. Okay, so because this one we don't know what is the V, V2, so we cannot do. So meaning that we can find here V12 first. Okay, because we have R12. Okay. So V12 is actually equals to our V total. Okay, and also equals to our V3 because it's connected in parallel if you refer to this case. Okay, and it's equals to 8 volt. So if you want to find I1, okay, I1, you can write it as V equals to IR, V equals to IR. Wait, okay. Okay, V equals to IR. So your I will equals to V over R. Okay, so since V is equals to just now is equals to 8, and your resistor for 1, 2, okay, is just now I want to is 16. Okay, if let's say I here I write I12 lah. Okay, and your V also V12, R also R12. Okay, meaning that the current that flowing through here is I12. Okay, we combine 1, 2. Okay, so you will get your I12 is equals to 0.55 ampere, 0.5 ampere. Okay, so actually your I12 is equals to I1, also equals to I2. Okay, because they are connected in series. Okay, so therefore, your I2, because you want to find 12 ohm, right? So it's actually we want to find I2. So I2 is actually equals to 0.5 ampere. Okay, so this is the current that flowing through the 12 ohm resistor. Okay, next, find the potential difference across the 4 ohm resistor. Okay, so 4 ohm resistor, you refer back 4 ohm resistor. Okay, so we want to find the potential V1 here. Okay, of course, when you want to find V1, you must have the current. Okay, V equals to IR. Okay, so we want to find 4 ohm. So V1 is equals to IR1. Okay, where V1, we don't know, but I we know because I12 equals to I1 equals to I2. So we know that is equals to 0.5. And the resistor is 4. So meaning that the potential difference is 2 volt. Okay, the potential difference is 2 volt. If V1 is 2 volt, okay, you refer back. If V1 is 2 volt, okay, meaning that V2 is equals to 6 volt. Okay, is equals to 6 volt because 2 plus 6 is equals to 8. Okay, and the current that flowing through the R3, of course, we can calculate as well. If you want to find I2, okay, is equals to V over R. Okay, so if let's say here I write I2, meaning that the potential is equals to 8 volt and the resistor is equals to 2 ohm. So the current that flowing through is 4 ampere. Okay, 4 ampere. So if you total up, just now is this is 4 ampere. Okay, this is 4 ampere. And then our I12 just now we found is 0.5. Okay, so we can know that actually I total is equals to 4.5 ampere. Okay, 4.5 ampere. If they ask you to find. Okay, okay, next one is example number 10. So example number 10 is your homework. This is your homework. Okay, this is your homework. So what should you do is you must refer to the junction here. Okay, this is the junction. Okay, junction X and Y, for example. Okay, so if let's say this is R1, this is R2, R3, R4, and also R5. Okay, so if you refer junction to junction, actually R1 and also R2 are series. Okay, they are series. So this is step 1. Okay, step 1. R1 and R2 are series. Okay, after that, if you simplify, okay, this is junction X. This is the junction Y. If you simplify, you will get this is R12, this is R3, R4, and also R5. Okay, so R2 and R12 and R3, because it's different wire, you see there's a junction here. So R3 and R12 actually are series or parallel. They are from different junction, not same wire. Then just now this one is no junction. Okay, R21 and R3 step 2 is in parallel. Okay, it's in parallel. Okay, so this is step 2. Okay, after that, after you simplify, you will get this one. Okay, when you combine, this is Y. After you combine, okay, this is your X. So if you combine, you will get R1, 2, 3. R1, 2, 3. And this is your R4. This is your R5. Okay, so after you simplify, you will get this diagram. Okay, you will get this diagram. Okay, so Just now, this is the junction. Okay, but after you simplify it, you will get, okay, you will get R1, 2, 3. Okay, so R1, 2, 3. Here another junction. Here another junction. Okay, so after that, we do it series. Series because R4 and 1, 2, 3 are connected in one wire. Okay, so step 3, you do series. Okay, you do series. So this is another junction. Okay, another junction. So another junction at here. This is, let's say, Z. Okay, so after that, so this is your R1, 2, 3, 4. And this is your R5. Okay, so they are not in series because these are different. There's a junction between them. Okay, there's a junction. So after that, finally, when you want to find R effective, you do it parallelly. You need parallel. So step 4 is parallel. Okay, so this is your homework for subtopic 3.5. Okay, thank you, class, and see you in the next subtopic. Okay, thank you. Bye-bye.